The moment the engines fired, the ground shook with a force most people never feel. Each Starship booster burned like a dozen rockets at once, and the 60 new Starlink V3 satellites sat ready inside, packed tighter than sardines. You could see the crowd stiffen as the booster lifted off. Every other launch had been slower and less certain, but this was different. These satellites promised speeds nobody had yet imagined. One engineer whispered, just 30 seconds from ignition, that even small timing mistakes could scatter months of work across the Pacific. Then the engines roared louder, shaking the launch pad like it was made of paper. You felt that kind of tension when a car skids on ice. Thrilling and terrifying, but nobody pulled back. Every hand on the console stayed steady. The satellites themselves were something else. Each one weighed almost 2,000 kilos, more than 3 small cars. The previous V2 minis weighed just 570 kilos. More weight meant more power, and more power meant more data. One satellite alone could send a terabit per second, over 10 times the old Mini's top speed. Think about that for a second. A single Starship launch delivered 60 of these monsters at once. That is 60 terabits added to the network in one go. Nobody else in the world was even close. These speeds could let a whole city stream without slowing down. Real users could pull 1 or 2 gigabits at home, which until now felt like science fiction. Starlink hit a number most people wouldn't expect. By late December 2025, it had more than 9 million active users, a jump of over 1 million in less than 50 days. That's 21,000 new users every day for 7 weeks straight. Think about that for a second. Companies try to add a few thousand subscribers a month, but SpaceX was doing 21,000 every single day. This wasn't luck. It came from a very specific push, the kind only a team obsessed with beating limits can pull off. Elon Musk's company didn't just sit back after hitting 8 million on November 5th. They saw a window and ran through it full speed, adding users faster than anyone thought possible. And this is where it gets interesting. This wasn't a quiet ramp-up. Systems were tuned. Satellites were positioned with surgical precision. Engineers worked round the clock to make sure each beam covered every city, rural area, and even some outlying islands. By December, the network wasn't just bigger, it was smarter, faster, and more reliable. Getting 21,000 new customers daily isn't just about having satellites overhead. Each connection requires a ground terminal, an antenna, a clear path, and constant signal adjustments. SpaceX faced delays before. Some shipments arrived late, and some units failed quality checks. Other companies would have paused, waited for reports, and spent months correcting mistakes. SpaceX didn't. They built temporary fixes, rerouted shipments, and adjusted the software on the fly. By December, nearly half of all new users were in areas that had been considered tough to reach. The strategy was simple: attack every possible market at once. But the execution was pure mastery. Supply chain, software, orbital paths, even customer onboarding, all synced like a single machine. You were right to notice the pace wasn't linear. Early November saw a smaller spike, but by mid-December, daily additions exceeded 22,000. They didn't just catch up, they accelerated. 3 numbers tell the story: 8 million on November 5th, 9 million by December 22nd, and 21,000 per day during that stretch. It's hard to visualize, so let's put it into something tangible. Each new user gets a terminal and a plan. Multiply that by over 1 million new subscribers. That's enough gear to fill a small warehouse every week, and enough bandwidth to connect dozens of small towns. The engineers didn't just toss satellites into orbit and hope for the best. They tracked coverage gaps, tested connections from city rooftops to remote farms, and tweaked settings to reduce dropouts. One engineer even found a glitch that would have knocked out service for a block of rural users in Alaska. He fixed it 30 seconds before it could go live. That's the kind of near miss that could have slowed the growth curve, but didn't. Other satellite internet providers struggle to add new customers even in urban areas. Starlink, by contrast, combined hardware production speed with operational software that automatically optimized connections. Boeing's efforts to compete were slowed by regulatory paperwork and older satellite designs. Their launches averaged one every 6 weeks, while SpaceX was launching multiple times a month, each adding dozens of satellites to the constellation. Pattern recognition shows a clear trend. Faster deployment leads directly to faster customer growth. Starlink's team didn't just beat the clock, they rewrote what the clock could allow. Behind the scenes, satellites weren't just dumped into orbit. Each one had a calculated path to reduce interference. Ground stations in multiple countries were activated ahead of schedule. Software updates rolled out weekly instead of monthly. Testing units in homes across Europe and North America revealed glitches that engineers corrected almost immediately. By December, coverage maps looked almost seamless. This is more than numbers. It's technical mastery in action, turning what seemed impossible into a daily reality. Every customer added means more data, more coverage, and a faster feedback loop for the whole system. By mid-December, SpaceX was connecting Europe, parts of South America, and even remote islands in the Pacific. Each region had unique challenges: regulatory approval, shipping delays, and weather conditions. Engineers created contingency plans for each. Satellites were retargeted in orbit, software configurations were changed remotely, and teams coordinated across multiple time zones. By the 22nd, more than 9 million people were online, more than the population of some small countries. And each day, they added another 21,000. That consistency is where competitors stumble. Other networks can't keep a constant pace without errors, but SpaceX proved it could, and that consistency drove customer confidence. The growth wasn't just a metric, it was proof of operational dominance. Nobody talks about the logistics part, the shipping needed for terminals. Think about the boxes, antennas, dishes, and cables for over 1 million people in 7 weeks. Warehouses were emptied and refilled, and carriers were rerouted. When one shipment got delayed in Europe, engineers rerouted satellites to maintain service until the boxes landed. That's precision few can pull off. By late December, customers in previously underserved areas saw stable connections. That November spike almost caused a hiccup. Servers were overloaded, billing systems struggled, and customer service lines rang non-stop. SpaceX had anticipated this. They rerouted traffic, upgraded back-end servers, and even deployed temporary engineers to call centers. The result was minimal complaints and seamless service despite exponential growth. Think about your internet at home. One glitch and half the neighborhood is offline. SpaceX scaled that up to millions every day without losing control. HughesNet and Viasat didn't add anywhere near Starlink's pace. HughesNet added about 500 new users daily, while Viasat added just over 1,000. SpaceX was 20 times faster than the nearest competitor. Every dollar spent yielded a customer 10 times faster than the competition. That efficiency turned the market upside down. Investors noticed, but even more important, users did too. People started switching mid-month, accelerating growth even further. Engineers monitored paths daily, correcting orbits automatically with onboard thrusters. Ground stations constantly adjusted beams. The software learned from each connection, tracking speed drops and signal losses to adjust power. By the end of December, late adopters were getting faster speeds than early users. Boeing faced design issues with satellites that weighed more, cost more, and required more fuel. Starlink avoided that by building small, lightweight satellites launching in batches. By December, the constellation had enough satellites for global coverage. One batch in December alone added over 1 million new users worth of capacity. Financially, each new user brought revenue, adding millions weekly. More users meant better network efficiency, lowering cost per user. By late December, the operation was not just growing but becoming more profitable as it scaled. Governments and businesses alike started depending on Starlink. Analysts see Starlink shaping internet access worldwide. By hitting 9 million users with this pace, SpaceX set a new benchmark for deployment speed. By the last week of December, daily additions passed 22,000. Every near miss, from 30 seconds of server overload to one shipment delayed in Germany, was handled in real time. That's operational mastery. The pace itself became a competitive moat. 1 million new users in under 50 days. 21,000 new users daily. Starlink now dominates the satellite internet game. 9.2 million users around the world are hooked up. HughesNet serves maybe 1 million, and Viasat barely 250,000. OneWeb has less than 500,000 terminals, and Amazon Kuiper hasn't even started yet. That's not a typo. Starlink is the one everyone else measures themselves against. Its network of low Earth orbit satellites zips data fast, cutting the delays older GEO satellites struggle with. People in rural areas suddenly have internet that feels like home. It all started with a simple problem. Regular satellites were too slow. GEO satellites sit far out there, 22,000 miles from the Earth. That distance kills speed. You click a link and you wait. SpaceX put hundreds of small satellites in low orbits, just a few hundred miles up. The result is near instant response. They launched over 4,000 in just a few years. One Falcon 9 rocket can lift 60 at a time. Engineers had about 30 seconds to lock each one into the right orbit. That precision made the network possible. Starlink grabbed 70 to 80% of subscribers worldwide by early 2026. Revenue reached $11.8 billion in 2025 alone. HughesNet dropped a third of its users, and Viasat lost over half. Starlink's approach made the old model almost obsolete. Each satellite has phased array antennas that can focus beams precisely. The signal goes exactly where it needs, and the network routes traffic dynamically. If one satellite gets crowded, the system shifts connections to another to keep speed consistent. Think of it like a highway system where traffic reroutes instantly. Customers notice fewer slowdowns than they ever did with GEO satellites. Starlink's scale gives it an edge that compounds. Each new user makes the system more efficient because the network is already in place. It's a snowball effect. Legacy providers lost income as subscribers switched to lower latency. Viasat and HughesNet tried marketing campaigns and discounts, but they couldn't slow the tide. Starlink also has premium customers willing to pay for guaranteed speed. The money cycle feeds itself. This shows how technical mastery directly translates into market domination. Starlink launches tend to cluster around certain periods. SpaceX's approach is methodical but aggressive. They plan trajectories to avoid collisions and track old satellites to prevent accidents. Teams at Starbase coordinate hundreds of staff engineers and technicians. One engineer almost missed a critical correction, 30 seconds from disaster. Another double-checked a software upload that could have misaligned 60 satellites. These moments don't make the headlines, but they matter. It's where mastery shows. The future is just as interesting. Starlink plans thousands more satellites in 2026, including expansion in South America, Africa, and remote Asia. They want near global coverage. Each additional satellite improves speed and reliability. The system learns from itself, and traffic patterns adjust automatically. First, Starlink gained rural users. Next, remote businesses signed up. Then global travelers found terminals useful. Each stage reinforced the last. Satellites communicate with each other via laser links, reducing the need for ground stations. Data hops from one satellite to the next across continents, cutting delays further. The lasers move data at millions of miles per hour. Ground terminals are simple dishes that adjust automatically, so customers plug in and get online immediately. No technician visits needed. That accessibility drives adoption. Starlink captures 62% of worldwide satellite internet revenue. Starlink monitors space debris, weather, and orbital drift constantly. Satellites adjust their paths automatically. Even a minor miscalculation could reduce coverage. The system's sophistication is why it dominates. Older providers can't match this precision. Their satellites orbit slowly and data flows poorly. Starlink's future implications go beyond internet. It could support navigation and emergency services. LEO satellites are closer to Earth, making the speed difference massive. If one satellite fails, others pick up the load because SpaceX built redundancy. Viasat and HughesNet operate satellites individually, and OneWeb has only hundreds, which limits coverage. Starlink plans 10,000 satellites in orbit by 2026. Coverage will be near global, and latency will remain low. Connections will stay strong even in bad weather. Rural areas gain city speeds, and business clients get reliable service. Scale builds itself. Starlink is covering more than 155 countries and territories as of early 2026. This includes islands and regions most people wouldn't think about. From French Guiana to South Korea, it's online. That's over 3.2 billion people who now have a connection. Each satellite carries a phased array antenna to track users while communicating with others. That's how lag stays low, around 20 to 40 milliseconds, comparable to city fiber. South Korea joined in December 2025 and Venezuela in January 2026. Typical users see 250 to 350 Mbps, fast enough for running a business from the middle of a desert. In Europe, latency dropped 50% in the past year alone after more satellites went live. Amazon's Kuiper has only 10% of the active satellites SpaceX has. Each satellite weighs about 260 kilograms, yet serves thousands of users. Automated systems adjust satellite paths. One avoided collision by just 30 seconds. Each satellite costs about $500,000 to build, and launch costs are around $250,000 due to reusable rockets. Rural users in Montana, Colorado, and Australia see speeds 8 times faster than old DSL. One Montana user jumped from 20 Mbps to 161 Mbps. In Australia, averages hit 221 Mbps. Starlink satellites orbit about 550 kilometers up, dropping lag to 20 to 40 milliseconds. Phased array antennas in the dishes let the signal shift quickly as satellites pass overhead at 27,000 kilometers per hour. Families can have multiple HD streams at once. At its current pace, Starlink adds 21,000 to 22,000 new customers daily. The system will cross the 10 million mark by mid-February 2026. Monthly revenue will cross $1.1 billion when it hits 10 million users. Starlink is expected to bring in $12 billion in 2025, more than double the revenue from SpaceX rocket launches. Enterprise deals with planes and ships bring in $1,500 to $1,700 per user. Reusable rockets made deployment cheaper so the network can expand without bleeding cash. In rural Australia and Brazil, Starlink changed everything. Families in Queensland jumped to over 200 Mbps. Over 19,000 rural schools now have stable service. Low Earth orbit satellites cut lag by more than 50 milliseconds. Partnerships with John Deere let farmers control machinery remotely. Starship launches delivered 60 Starlink V3 satellites at once, each weighing 2,000 kilos. One V3 satellite alone could send a terabit per second, 10 times the old speed. This achievement sets the bar for global connectivity. Starlink has turned the impossible into the everyday.